looks like everyone's just getting situated. If you've got a pen and pencil or paper, that's going to be really helpful for today. Also, if you have a calculator on hand, or also if your phone could work as a calculator, that'll be helpful as well. So you could go ahead and prepare those materials, and then we'll jump right in here. All right. Hi, everyone, and good morning to all of y'all in Guam and CNMI. Welcome to session 4 of our U.S. Territories Wastewater Operator Training Series. This session is going to cover wastewater math, applied wastewater math, looking at area, volume, and pressure today. So we're going to be building on what we did last a couple of weeks ago in our basic math class. And just kind of building on that and moving along and building some more really helpful skills for you all, hopefully, when you go to take your operating exams and also when you go to do your work out in the field. So I'm Shannon Pepper. It's good to see you all again. I'm a water utility trainer and specialist at the Southwest Environmental Finance Center, and my email is right there on the screen. If you have any questions following today's webinar, please feel free to reach out to me, and I'd be happy to respond at any time. So go ahead and take that email down if you want to reach out. We're the Southwest Environmental Finance Center, and we are part of the UNM School of Engineering. And this training series is funded with support from the US EPA to bring operator certification training to all of y'all. So here's a little bit about Zoom meeting controls. Hopefully this is not new stuff for you, but just a quick reminder, you've got this control bar at the bottom of your screen, and it has this black bar. It's got all these little icons. Please especially pay attention to the mute and unmute button, and also video on and off. If you're asking a question, feel free to leave yourself unmuted. If you're in a big room, sometimes it's hard to get yourself unmuted, so you're also welcome to unmute in that case. But for the most part, we'll stay muted so that we can preserve a little bit of sound quality for our recording today. There's also a chat option. I'll probably ask you to utilize the chat at some point. Also, it's a great place to drop questions. I'll try to pause for questions at different points, but do make sure that you use the chat, and Valeria will be monitoring that for us today and making sure that all your questions get answered. So feel free to drop a question in the chat or just jump in. I'm happy to answer questions as we go. So this training series is meant to cover a lot of the basic core requirements for the WPI ABC operator certification exam. We're going to cover all of your need to know criteria, and then also a little bit of the higher level criteria as well. We're mostly looking at covering wastewater treatment operator classes 1 and 2 for this series. And again, we might cover a little bit more advanced things later on, but that's kind of where we're focusing for this series. Here's our schedule for 2025. So we're on session 4, and it is here 5th of August. And then our next webinars in the series are going to be on collection systems. These are bi-weekly webinars, so if you're attending the whole series, you'll be back in a couple of weeks for the next one. And this is the website where you can find that list of trainings, and also you can find any information. You can also find recordings on this website. So this is a really important one if you have missed a session and want to go back and either get your credit or just review. That's really helpful for the math as well to review. So take a note on this website. That'll be helpful for you. Do make sure that you sign in for every one of these sessions to make sure that you're getting credit for attending them. There should be a facilitator at your location with an attendance list, and that will ensure that you're getting credit for attending these webinars. So let's we're going to dive right into surface area basics today. So a surface area, when we're talking about surface area, we're basically talking about two-dimensional space. And if we're thinking about two-dimensional space, these are some of the units that you might encounter, or some of the units that will tell you that you're working with area. you might see inches squared, and that's what that little 2 up above the inches means. It just means squared, you could say. It means inches times inches. And we'll go over a little bit why that is as we dive into surface area. You might be looking at feet squared, miles squared, meters squared. Also, acres is another way to measure flat two-dimensional space. So think about in your head here, where in water systems in wastewater systems might you encounter surface area calculations, right? So here are some of the ways that surface area comes into play for wastewater operations. You might need to calculate the surface area of a pond to make sure that you're putting the proper amount of liner in. Same goes for weed fabric around the edges of your lagoons, potentially, or buildings. You might be looking at paint. How much paint do you need to buy and how much will you expect to use? The surface area calculations are really helpful for that. They're also helpful for calculating building materials and siding and these kinds of things. So anytime you're dealing with some kind of flat space, two-dimensional space, we're going to be thinking about surface area. And here's some more just direct examples, wastewater system operations. We could be calculating copper sulfite applications for algae control, maybe in pounds per acre, right? So copper sulfate in pounds, and then looking at the acre of space that we'll need to cover it. Could be looking at filter backwash rise rates. So that calculation is in your formula sheet. And actually, I'll just mention too that the formula sheet is in the chat. I already put it in the chat. I think that everyone should be able to see it. Let me know if you can't. But that formula sheet is going to be available to you when you take your exam. So I'll reference it a lot today, and it's a really useful resource to just start practicing with and getting familiar with, because you can look up all sorts of formulas on that sheet, this one as well. Might also be looking at surface loading rates or surface overflow rates. So that's another time that we're going to be dealing with and calculating surface area. And here are a few common surface area equations. Again, these are going to be directly from your formula sheet. We just took screenshots and put them here, so you have access to these when you're taking your exam. We've got area of a circle and a couple of different ways to calculate that. That's going to be really important because there are a lot of circular objects in your work as wastewater operators. Tanks, for instance, the top of a tank is circular. Pipes, circular as well. Also looking at area of a rectangle, that's going to be a really common shape that you'll encounter as well. And then we've got, cylinders, cones, and triangles as well. So all of these are very important. We're going to be practicing most today in this section with area of a circle and area of a rectangle. So let's look at a surface area example here. So say you need to buy some new liner for your water pond, and this pond is 64 feet long and 32 feet wide. So how many square feet do you need to order of that liner? So we're going to be looking here at area, right? Area of a rectangle. And area is basically length times width. So we're going to be looking at the length is the long side of your rectangle. It's in that blue box that you can see on the screen here. And then width is going to be the shorter side. So length in this case, because we know that it's 64 long and 32 wide, all we have to do is plug that 64 and that 32 into our equation. And make sure that you're keeping units in these calculations as well, because what happens next, when you multiply the 64 times 32, you'll get 2,048. And then what you're also doing is multiplying the feet unit by another feet unit. And anytime you have two separate units like that and you multiply them together, then you end up with, in your answer, you'll have feet squared. So that's that little 2 in the corner. If we were doing a calculation of 3 different multiplications together, feet times feet times feet, then it would be feet to the third, or feet cubed is another way to say that. But in this case, because we're calculating area and it's just length times width, we've got 2,048 feet squared, and that's how we would calculate the area of that particular rectangle. Let's also look at example of a surface area calculations for a circle. So in this problem, we have what is the surface area in square feet of a circular sedimentation basin that's 60 feet in diameter. So here we have a couple of different options for our area calculation. On your formula sheet, you get both of these calculations. And so one of your options is to take the number 0.785 and multiply it by the diameter squared. Okay, so that's one option. Another option is to take 3.14, which is pi. This might sound familiar. So pi times the radius squared. So pi r squared is going to be our calculation for the area of a circle as well. I personally, in this case, I like to work with the pi r squared because it's a really common formula and it's really easy for me to remember because I can remember that pi is 3.14. But it's really up to you. You could use either in this case. Just remember that the radius is 1/2 the diameter. So if the diameter is the length from one end of a circle to the other, then the radius is just going to be half that length. So in this case, because we know that the diameter is 60 feet, we can calculate the radius as 30 feet, because 30 is half of 60. So let's go ahead and plug that into our equation here. We can get 3.14, which is pi, times 30 feet squared, right? Because the radius is 30 feet, and then we need to make sure that we're squaring that radius. And so if we do that, we get 30, and we can take this individually. We could go 30 squared, 30 feet squared, and then that gives us 900 feet squared. If we go 30 times 30, we get 900. And then we'll multiply that by our pi, which is 3.14, and that gives us a final answer of 2,826 feet squared. So that's also correct because we know that we're trying to calculate area, so we're going to expect to end up with feet squared. We're working with feet, and that tells us that we're on the right track with keeping up with our units during those calculations. So let me know, does anybody have any questions at this point about any of those calculations or?
Yes, no questions.
Okay. Also feel free if you want to drop it in the chat, that's totally fine. And Valeria will catch up with me. But if we don't have any questions so far, we're going to move on to a practice problem. So here's our practice problem. I'm going to give you all a chance to check this out and work through it on your own or with the people that you're in the room with. And then at the end, I'm going to give you, let's see, I'll give you 3 minutes for this problem. And then at the end of those 3 minutes, I'll have Valeria put up a poll. And then you all can submit your answers through that poll, and we can see how we do. And those answers will be anonymous. It's not like everyone's going to see whether you got it right or wrong, but it'll just give me a sense for how everybody's following along and understanding things. So for this question, we've got, how many square feet of wheat cloth will you have to order to cover the fenced area around your 25-foot diameter tank? That fenced area is 90 feet by 90 feet. Okay. So knowing that, and given that you have these calculations down here, you have area of a rectangle is length times width, and then your two options for calculating the area of a circle. So go ahead and I'll let you all figure that out on your own, and then we'll come back together in a few minutes and talk about the answers. Also, if you get any questions as you're working through this problem, you can just shout them out or drop them in the chat. And I'm happy to talk through that.
You can use the calculator. Cousin.
All right, Valeria, would you go ahead and launch that poll, that first question? Great. And you'll notice that in the answers for these poll questions, there's like a little foot with a little caret and then a 2. That's just another way of writing that feet squared. So it's this, those are going to be the same essentially as the answers that you see on the PowerPoint screen. It's just that the Zoom polls are not quite smart enough to know what that little symbol is, so to write it in shorthand.
C? Everyone has to agree. Is it C? This? Anthony? Anthony?
Yeah.
Okay, I'm going to keep that poll open for another 10 seconds. Pop your answers in there if you get a chance. Can see how we did. Okay, closing the poll. Thanks everyone for participating if you did. Great, so majority answered C. So let's go ahead and see how we did here. So we're looking at how many square feet of weed cloth, right? So square feet would tell us that we're dealing with area. So that's the first thing we want to pay attention to. To cover the fenced area around your 25-foot diameter tank. So you know that your tank, which is a cylinder in shape, has a 25-foot diameter, and the fenced area is 90 by 90. So this is an example of a question that gives you a little more information than you necessarily need. So we're also looking at, this is a kind of complex one because we're calculating both the area of the fenced area, but then we also have this cylinder in the middle, which are our circle looking from above, which is the tank. So let's go through how we might work that out. So area we know of a rectangle or a square is going to be length times width. And then what we also would want to do, right, because we don't want to cover, we can't cover this part that is covered in our tank in weed cloth, right? So we kind of have to act like we're just cutting that out from our calculations of weed cloth. And so we can write that out in this equation by just going length times width, which is going to be our area of our bigger shape, which is the fenced area, minus this area of our tank. which is going to be that calculation for area of a circle, which is 3.14 times radius squared. So that gives us an area. We calculate, we know it's length 90, width 90, so 90 times 90 feet minus our 3.14 times the radius of the tank, which is 12.5. We know 12.5 because if it's a 25-foot diameter and our radius is going to be half that diameter, and then square that. So if we work that out kind of piece by piece, we get 90 times 90 feet times 90 feet, and that's going to give us 8,100 feet squared minus pi, which is 3.14 times 156.25 feet squared. So if we take what's inside that parenthesis there and then square it, so 12.5 squared is 156.25, and then feet squared is just feet squared. And then we have an area of 8,100 feet squared, and we'll subtract that from 3.14 times our calculation for the area of the kind of cut out of our tank. And that leaves us with a final answer of 7,610 feet squared. So that's going to be our answer for that one. So that's kind of tricky, right? I mean, it involves a couple of different calculations that you have to do. And that will be common on the exam. It won't necessarily be super straightforward, but if in this case, it can really help if you have a piece of scratch paper and a pencil to just draw it out. Draw it looking down from above, draw your dimensions. And that's going to help you visualize what you need to do and how you need to set up those equations in order to get your answer. So hopefully that makes sense. Are there any questions on that one? On how we got there in the end?
Yeah, you use two formulas, for example. Formula is really important.
Okay. So let's get into some 3D math now. So we were working in the kind of flat two-dimensional plane just now. We're going to do a little bit in 3 dimensions because a lot of times we're working in 3 dimensions. We sometimes calculate surface area, but we're also dealing with volume. So that's what we're talking about when we say 3D. So how we would calculate volume of a box, we'd start with that 2D calculation or the flat plane, so length times width, but then we add that third dimension in there. So we would also multiply by height. So volume of a box or a rectangle is going to be length times width times height, using all 3 of those dimensions. So in this problem here, what is the volume in gallons of a rectangular tank with the dimensions of 30 feet long, 50 feet wide, 10 feet wide and 15 feet high? So to calculate that volume, we're just going to take the length, multiply it by the width, and then multiply it by the height. So that's going to be 30 times 10 times 15. And then as we're multiplying those 1-foot units together, that's also going to give us an answer that is 4,500 feet cubed. This answer on the screen here is missing those units, but it would be feet to the third. Very important. There it is. So 4,500 feet to the third because we're multiplying those little feet units 3 times together. And that's what gives us that cubed in the end. That's another reason why it's really important to track your units when you're doing your calculations. If you've written out an equation, because this is applied, all this math is applied, you're kind of always working with units. Units just tell you what your number means, basically, how it's assigned. So it's good to keep track of those in your calculations because you'll be working with them. Okay. And then we can also think about this because remember that we're calculating volume in gallons of a rectangular tank. So we've calculated the volume, right? Now we need to get to the gallons that are going to fill it. And so because we ended on this with this feet squared, right? Also on your calculation sheet, you have volume conversions. So one of those useful conversions is that 1 cubic foot of water, or 1 foot to the third of water, equals 7.48 gallons. So what we can do is a little unit conversion here. So this is something we covered in our last class, where we introduced the idea of unit conversions. So because we have in this calculation here, we can multiply 4,500 feet cubed times this conversion factor, which is 7.48 gallons for every 1 cubic foot. And here we can calculate, we can cancel out these feet cubed, because there's one on the top. There's like a little invisible one below this 4,500 in our conversion. Cancel out those feet cubed, and I also like to write it out in this sort of grid format. I find this easier to kind of understand and see what's happening. So we're going to cancel out those cubic feet on the bottom, and then that's going to leave us with just gallons as our unit, which is good because that's what we're trying to calculate. And then we just multiply across the top here. 1 times 1 is 2. So all we have to do is go 4,500 times 7.48, and we're left with 33,660 gallons as our final answer for our volume calculation. Any questions on that? How we got there? Yeah, and if unit conversions can be really tricky, I know. So, and they're really common for these exams and also for applied work, applied math in your work. So if you want another tutorial on units, there's a lot of good videos online, but then also you can just revisit the first math course that we did a couple of weeks ago, and that has a little deeper explanation of unit conversions. It's an important one. Okay, but wait. Do we really know our volume that accurately, right? So we're going to talk a little bit for a moment about significant figures. So this is kind of a common thing that you'll see on the exam. How many significant figures did we start with? Well, a significant figure just basically means how accurate do we want our final number to be? Because we could have a really detailed, long number that comes out of our calculation, but maybe we need to simplify that either for our own purposes or in order to make sure that we're doing the right calculations for the problem. So in the original question, each of these numbers, 30, 10, 15, are two significant figures, right? But then we have this 7.48 in our gallons calculation, which kind of bumps that number of significant figures up to 3. But because 30, 10, and 15 are in the answer here, or sorry, in the question, then we're going to go for that same number of significant figures in our answer. And because these exams are multiple choice, they won't, like, you'll have a sense of what number you should end up with based on the answers that you're given of the multiple choices. So you can also use that to determine what kind of significant figures you're looking for in these calculations, but make sure that you're paying attention to that as you go through and do your calculations for each of your problems. Okay. So we're going to do another practice problem here. This is going to be a volume of a box plus a conversion, kind of like what we just did. And this is just going to be part 1 of that question. So for part 1, we're going to dig a trench to put in a new section of pipe in the ground. The trench is going to be 4 feet wide, 4 feet deep, 2 feet wide, and 200 feet long. How many cubic feet of dirt did you excavate? So basically, what is the space of that trench shape that we just got? And we're kind of assuming that a trench is basically a rectangle.
Each other, that way, you guys are
So
on.
I'll give you all a chance to do this problem. I will give you 3 minutes once again, and then we'll move on. There's another part to this problem as well. So I'll throw that up there, and then we'll do some polling so you can put your answers in and see how you did at the very end. But first, I'll give you a chance to do this part 1 of this practice question. And once again, please feel free to shout out any questions if you have any.
Share your ideas. See how you guys did it? That way we can answer. You put a poll. So is your answer also 1,600? How are you to? 1,600? Yeah.
Okay. So I'm going to go ahead and move on to the next part of this question here. So that was part one. And for part one, oh, we have the calculations up here still. That's all right. So you should have calculated length times width times height, which is going to be 200 feet times 2 feet times 4 feet, right? And then that's going to give us a final answer of 1,600 or 1,600 feet cubed. Okay, so let's move on to the next part here. So for part two, we're going to fill in our 1,600 foot cubed hole. And we're going to need to order fill dirt, and it's sold by the truckload. So how many truckloads of fill dirt, are you going to need if one truck holds 10 cubic yards? Okay, so it's really common, right, for truckloads to be measured in cubic yards rather than cubic feet. So we're going to need to go from cubic feet to cubic yards. And for conversion factors, we know, and this is on our formula sheet, that 1 yard is equal to 3 feet, or 1 cubic yard is equal to 27 cubic feet. Okay. So knowing that, we have our cubic feet, right? So we just need to calculate how much that is, how much 1,600 cubic feet would translate to yards, to cubic yards. So I'm gonna go ahead and give you a couple minutes to work that out, and then we'll throw up our poll questions. Okay, would you go ahead and put that poll up, Valeria? Awesome. So here we have both part one and part two, and part one we do already have the answer to, so that one should be pretty easy. But it's part two that's going to be the kind of final challenge here. So when you get a chance and you get your answers, go ahead and throw them in the poll. See how we did.
Ashley?
So since it says cubic yards, cubic yards, like this contains 27 feet squared. Yeah. Using the max of 27 feet squared, 70.
if you're having trouble with this one, just remember that when we're doing our conversions, you can set it up in that little grid form where you take the number that you want to convert, and that's going to go on the left side of your grid, and just put that with your units over 1. And then on the other side of your grid, on the top, you'll have your conversion factor, with the unit that you want to get to on the top, and then the unit that you're trying to cancel out in that conversion on the bottom. So that's kind of how you would set up that grid. If you're having a hard time with your conversion, that's what I would recommend trying.
Okay.
Okay. So I'm going to go ahead and give everyone
You guys have your paper?
20 more seconds to put your answers in, and then I'll close the poll.
This, is this one's gonna help? So next time bring your conversions on it that we gave you guys last week.
Okay, I'm going to go ahead and end the poll. Thanks for participating. And I'll go ahead and share those results with you all as well. So for that first one, this is kind of a tricky thing that we threw in there just to highlight that, you know, you got to pay attention to your units. So we had two answers that had 1,600 in them, and one of them, the unit is feet squared, and then the other one is cubic feet. And because we're calculating volume, we know that we should end up with cubic feet, right? Because feet squared refers to surface area, similar, but not quite. We want to look for that 3-dimensional volume. Okay, and then for part 2, for volume of a box and conversion, let's look at how we got there. And thanks everyone for participating in that poll. So when we look at this conversion here, we know based on our formula sheet that 1 yard equals 3 feet. So we're going to start with our number that we calculated for part 1, 1,600 cubic feet. That's our volume. And then we have this conversion, right? And you know, this is one way to do it. Because we have this cubic yard to cubic feet calculation, that's probably going to be the simplest way, but we also just wanted to show you that you can also start with this conversion that is just, it's kind of doesn't take that shortcut. It kind of is for long. But basically we start with this 1,600 cubic feet, which is just 1 foot times 1 foot times 1 foot, and put that in our grid over 1. And then because we're dealing with 3-dimensional space, you know, we can look at it as a conversion of one yard for every 3 feet 3 different times. All of those feet calculations would cancel out, and we're left with cubic yards. So that's one way of looking at it. And then, you know, if we're looking at 10 cubic yards, one truckload, then here's how we would potentially calculate that, right? So we have the volume here that we calculated in the last part, 59 cubic yards over 1. And then our conversion factor is 10 cubic yards for 1 truckload. And so if we cancel those cubic yards out in our grid, because you've got 1 on the top, 1 on the bottom, you divide them and they cancel out. And you're left with 59 divided by 10, which is 6 truckloads. So that is going to be our final answer for that one. So good job, those of you who filled that out, you got it right. That's a complex one, and that involves like a little bit more complicated conversions. So that would be one to practice too if you kind of struggled with it. You'll have access to the recording of this, so you can also go back and kind of practice that yourself, and also have this walkthrough after that if you struggled on this one. Okay, Let's look at volume of a cylinder. So we have a lot of cylinder shapes in our work as operators, tanks, pipes, wells, all of those are cylindrical in shape. So when we're talking about, volume of a cylinder, um, we kind of think about it as a bunch of areas all kind of stacked on top of each other, right? And can remember that the area of a circle is 0.785 times the diameter squared, or pi times the radius squared. So a volume of a cylinder equals 0.785 times the diameter squared times also the height, because we're taking all those kind of flat planes and just multiplying them by the height of the object. And that's going to give us our final volume. So another way to calculate that, if you're going further for the pi and radius option, is to go 3.14, which is pi times radius squared times the height of your object. So that's how we calculate volume of a cylinder. So like area of a circle, we have two different options, depending on what you want to use and also what the question gives you, whatever you're most comfortable with. I typically use radius because I'm most familiar with that pi r squared calculation. Feel comfortable with it. But again, the diameter is just 2 times the radius, or the radius is half the diameter. So let's look at an example of calculating the volume of a cylinder here. So let's say you're trying to figure out how much water is in your water system at any given point in time. You have one storage tank with a diameter of 10 feet, and it is 16 feet tall and 4,000 feet of water lines that are 8 inches in diameter. What is the volume of water in the full tank plus the lines? Okay. So we're calculating the volume of this entire system. So we're not just doing the tank, right? We're doing also the lines. Let's look at that. So let's first find the volume of the tank. We'll break it into 2 different calculations. So for the volume of the tank, if we do that pi times radius times height calculation, radius squared times height, 3.14 times radius squared times the height. And in this equation, because our radius, we know that the diameter is 10 feet, and the radius is half the diameter. We can go 10 feet divided by 2 will be our radius, and then square that times 16 feet. If we do that first, remembering our order of operations, our PEMDAS from last time, parentheses go first. So we'll do the parentheses, and then we'll do the exponent. So do the parentheses, 10 over 2 is 5. We'll square that. And so then we get 3.14 times 25 feet squared times 16 feet. We'll do 3.14 times 25 first. That gives us 78.5 feet squared times 16 feet. And that gives us a final answer of a volume of 1,260 feet cubed, feet to the third. So that's the volume of our tank, right? So now let's calculate the volume that is in the pipes. So we'll first convert, we know that our water lines are 8 inches in diameter, and we'll need to convert those inches to feet for our calculations. So we know that 1 foot, in 1 foot, there's 12 inches. In our diameter of the pipe, we've got 8 inches times 1 foot over 12, because we're trying to convert that 8 inches to feet. So our conversion factor is 12 inches. We cancel those inches, cancel out those units, and now we'll just go 8 divided by 12, and that's going to give us an answer of 0.67 feet, 2/3 of a foot. Okay. So then we can use this in our volume calculation. So 3.14 times the radius, which is half the diameter. So we just found that diameter of the pipe, right? It's 0.67 feet. So in order to find the radius, we'll need to divide that by 2. First things first. So we'll do that inside the parentheses, and that gives us 0.67 over 2 is 0.33. Then we'll do what's also again inside of those that wider set of parentheses, and that gives us 0.11. If we go 0.33 squared, really when you square a decimal, it gets smaller. So that's something that you can expect in these calculations. So if we go 0.11 squared, or or sorry, 0.33 squared, or 0.33 times 0.33, we get 0.11. We'll multiply that by pi, and then also finally by the length, which is 4,000 feet, because we know we have 4,000 feet of water lines. And then that leaves us with 0.35 feet squared times 4,000 feet. And if we multiply those two together, we finally get the volume of 1,400 cubic feet. Okay. And then to find the total volume of water for both of those, we'll just need to add those two answers together, right? So we calculated them individually, we'll add them together, and that gives us a final answer of 2,660 feet cubed. Okay. So let's go ahead. Oh, sorry. And then the total volume in the system, because we're paying attention to our significant figures here, I got a little ahead of myself. 2,660, that's 3 significant figures. But based on the numbers that were given in the question, we're going to go for 2 significant figures, so we round up. So because that 2,660 is closer to 2,700 than it is to 2,600, we'll round up to 2,700 feet cubed. Okay. So I'm gonna let you all have a crack at this too. Let's look at the volume of a cylinder. So in this example, this question, we've got a tank that is 42 feet in diameter and has 56 feet of water in it. How many gallons of water are in the tank? So we get these calculations to work with, volume of a cylinder, both working with either the radius or the diameter as your calculation input. And then we know that a cubic foot of water is equal to 7.48 gallons. So take these conversion factors, think about how you'll set up this problem and the equations. I'll let you all have 3 minutes to work on this on your own, and then we'll come back together. We'll put the poll up, and I'll let you put your answers in. We can see how we did and walk through the question. So go ahead, see if you can find the volume of this cylinder. And notice too in this question that you're given 56 feet of water, right? Because you're measuring the height. And you will have to do a conversion at some point because you got to end up with gallons. So keep that in mind as you work through your calculations. Okay, I'm gonna go ahead and close the poll here. And here's the results. Let's go ahead and see how we did. So calculating the volume of this cylinder. So remembering that the volume of a cylinder, I'm going to go ahead and use this equation. So 3.14 times the radius squared times 56 feet. So if we put in 21 feet as our radius, and then times a height of 56. Oops, sorry, that's actually, that's not quite right. Let's see. I must have put that in the slide wrong. The diameter rate is half of 45, so it should actually be 22.5, but let's go ahead and go through with this calculation here. So let's see. Let's do 3.14 times 22.5 squared times 56. Right, so if we use the numbers that were, oh, I see. So that it's just that on this diagram here, the diameter is written incorrectly. Sorry about that, everyone. So I hope nobody is too confused, but if you took this 42 number as your diameter rather than what was written over here above the cylinder, that should give you a radius of 21 feet because it's half of 42. If you looked at this diameter number over on top of the graphic and you put 22.5, then you would get a higher number. You would have gotten 89,019 cubic feet as your volume. So if you did that, sorry about that, and I'm sorry about the error on the slide here. But yes, that would be your answer. So sorry if that was confusing for you all, but we're going to go ahead and take what's written in the question here. So that radius of 21. And then that gives us a volume of 77,545 cubic feet. And then we've got to convert that to gallons, right? So if we know that we have 7.48 gallons in 1 cubic foot of water, then we can take this volume calculation, put it into our conversion grid. So we start with 77,545 cubic feet divided by 1. And then on the other side, we'll put our conversion factors, 7.48 gallons over 1 cubic foot. And then that gives us a final answer. If we multiply across 77,545 times 7.48 gallons, that gives us a final answer of 580,000 gallons. And that's how much water we have in our tank. And again, if you used the other diameter number that's on the screen here, you would have gotten a slightly different answer. So sorry about that, but hopefully the practice was still helpful in watching that go through there. Okay, so we have just a few minutes left, and I just wanted to quickly go over pressure. So when we're talking about water pressure, we're working with a few different kinds of units. We're usually working with feet of head, which is measured in feet, pounds per square inch, which is also written as PSI. We could be looking at torrs, pascals, bars, millimeters of mercury. And the minimum pressure required in our distribution systems, right, is 20 PSI, and the maximum recommended is 100. So staying within that range is really important, and being able to calculate your water pressure is really important to making sure that you're staying within that safe operating range. And for water pressure and system operations, it's really just important to understand how elevation changes affect pressure in your system, how water loss control can be optimized through your good pressure management, right? Not having too much or too little water in your system, or pressure in your system, and then understanding and controlling tank levels to meet pressure goals for the distribution system. So these are all really critical for operators. And this is really, I would say, um, just a kind of looking at pressure and feet of head here. So, tank A is really tall and skinny. Tank B is the same height, but it's a lot fatter. If each tank has a pressure gauge at the base, which tank do you think has the highest pressure? That's kind of a trick question because A actually equals B. The amount of how we calculate pressure is based on the height of the tank rather than the size or the overall volume of the tank. So with that in mind, and thinking about pressure and feet of head, the volume of the water isn't what's important, right? It's the height of the feet of head that matters in those calculations. So there's a direct relationship between feet of head and water pressure in PSI. These are some really useful conversions. Also on your calculation sheet, 1 foot of water is equal to 0.433 PSI, and 1 pound per square inch is equal to 2.31 feet of water. So that'll be an important one to pay attention to on your formula sheet. So if we're looking at calculating pressure, let's take a look at an example here. Your storage tank has 53 feet of water in it. So what is the water pressure in pounds per square inch at the base of your storage tank? So taking these conversion factors again, we know that our height is 53 feet, right? And we've got our pressure gauge here at the bottom of our tank. So what we're going to need to do is convert our 53 feet, that's our height, and then we have our pounds per square inch conversion factor. So we know that 1 foot of water, so for every foot of water that's in this tank in the height, is equal to 0.433 pounds per square inch. And so what we can do here is put this into our little conversion grid. We've got 53 feet over 1, on one side of our grid, and then the other side of the grid, we've got 0.433 psi over 1 foot. Those feet cancel out, and we're left, if we multiply across the top of the grid, we've got 53 times 0.433 psi, and that equals 53 is 23 psi, 23 pounds per square inch. Okay, so there's an example. This is a problem that I was going to have you all work through, but in the interest of time, I think I'll just treat this as another example, just so that we can make sure that we get you all out on time today. So on this pressure practice calculation, we've got a storage tank. It's on a hill, and it's 100 feet above a pump house, and it's got 345,000 gallons of water, water height of 34 feet. So we're going to calculate the pounds per square inch pressure in the pump house. So we can if we can kind of work to visualize this here, remember that 1 pound per square inch has this conversion factor. Oops, sorry. And we're looking at 34 feet of water at the top of the tank, 100 feet of water on that downhill, and then the pump house at the bottom here. And we're going to add those feet together, and that's going to give us our total height. And then if we're calculating using our conversion factors, that's going to give us a total pressure in the system of 58 psi at the pump house. We kind of take that feet of water and put it into our conversion grid, 1 pound per square inch being 2.31 feet of water. So, setting that up, making sure that you have that grid all set up correctly. You take that total height calculation that you did for the system, and then you have 1 pound per square inch is equal to 2.31 feet of water. You can cancel those feet out, and then you will divide 134 by 2.31, and that's going to give you a final answer of 58 pounds per square inch for that one. So that's another example of how that works in practice. So I'm going to go ahead and finish up here. If you have any questions and are able to stick around, I'm happy to stick around for another couple minutes and answer them. Thanks for attending today. Really appreciate your time. Hope you all have a great day. The next webinar coming up in this series is going to be collection systems. It's going to be gravity systems, and that'll be on the 19th of August. It might be a slightly different date for you all, actually, but that next training is going to be on that training website that I showed at the beginning. I'm happy to drop that website in the chat too if anybody doesn't have that training website saved yet. Also, please feel free to reach out to me. My email's on the screen here, and I'm happy to talk through anything that we went over today if you have any more questions. Also, I will stick around for a couple minutes right now in case you have any more. But thank you all for your time, and hope you have a great day.